Hi, thanks for checking in. Here is our next video lesson. This is the next lesson in our unit talking about functions, and specifically we are talking about linear equations. Remember, these are equations that can be graphed as straight lines. So we're going to kind of continue on with all the things there are to learn about linear equations and graphing linear equations as straight lines on the coordinate plane. That brings us to this goal for this video. The goal for this lesson is that you will be able to find the slope of a line if you are given the graph of that line. Now, you probably don't even know what slope is, and that's okay. Remember, we're going to baby step our way through this. So I'm going to do the best I can to describe what slope is to you, and then we're going to continue to work on slope for the next few lessons. So again, by the end of this lesson, I hope that you'll be able to tell the slope of a line if you are looking at the graph of that straight line. Here's what slope is. Slope is almost always represented by the variable m, right here. Slope of a line is called m. Don't ask me why. I'm sure there's a great reason. I just don't know what it is. So the slope, or m, of a line is a ratio means fraction, of the change in y, otherwise known as the rise, to the change in x, otherwise known as the run, between any 2 points that are on the line. Wow, that sounds confusing. Well, at first it might be a little confusing, but we're going to baby step our way through this. So the next thing you can see here, kind of colorfully displayed on this web or this page here, is the different ways that we can represent slope or calculate slope. And today I'm going to kind of blast through all three ways, but we're really going to focus on just one of these ways today. So it says here that m, slope, is equal to rise over run. I'll explain more of that in a minute, and that's the one we're really going to be working on today. It is also equal to the change in y values over the change in x values. We'll do that, I think, tomorrow. And then it is also equal to y2 minus y1 over x2 minus x1. And it really all means the same thing. Calling slope rise over run, or change in y over change in x, or y2 minus y1 over x2 minus x1, it's all really just the same thing. There's just different ways to kind of get to the final answer of what slope is. And today I circled rise over run. That's the one that we're really going to be focusing on in this lesson. So first of all, let me tell you what slope is in my own words. In my own words, slope is the steepness of a line. How steep is it? And is it a line that has a positive slope, or is it a line that has a negative slope? So let's talk about positive slope and negative slope here for a moment. You see these two graphs. On the left side, there is a line drawn that has positive slope. When we look at a line and we determine if it's positive or negative, we look at where the line begins on the left side of the graph. So I start my eyeballs down here, and I follow the line to the right, working our way to the right, and you'll see that it's going in the upward direction to the right. So if you were riding your bicycle, starting on the left of this graph, working your way over to the right of this graph, you would be going uphill. That is a positive slope. If the line rises from left to right, it's positive slope. You would be going uphill, pedaling pretty hard to get up that hill. On the other hand, if you look at your line and you start on the left side, so I'm starting here on the left side of the graph, and I follow the line and I notice that it's going down to the right. It's going in the down direction. Or this is you right here and you're on your bicycle and you start at this beginning point and you're riding your bike, you're going to be riding your bike downhill. That's called a negative slope. So in this example, the line falls from left to right. So we always look at our graphs from the left side of the graph to the right side of the graph, and we follow the line. If it's going up to the right, it's positive slope. Down to the right, it's negative slope. Now, I said a few minutes ago that it was rise over run. A lot of kids don't know about rise and run. Some kids, maybe they do. Here's when I've experienced the terms rise and run in the real world situation. I had to buy carpet one time for a set of stairs in my house. And when the carpet guy came to measure, right, they have to come and measure, figure out how much carpet you need to buy, I noticed that when he measured my stairs, he measured how tall the stair was, and then how much room there was to put my foot on that stair. And then how tall the next stair was, and how much room there was to put my foot on that step. And how tall was it, and how much room was there. And this is the rise, and this is the run. So when we talk about rise and run, I always think about a set of stairs, because he had to measure to put carpet on the entire step, not just the part where I was putting my foot, right? Most steps have carpeting up and then forward, and then up and then forward, and that is called rise and run. And that's really like the real world application here, rise and run. So this is the rise. The part that goes up and down, that's called the rise, which, if you think about the coordinate plane, which axis is the up and down axis? It's the y-axis. And then, when you actually take the step, after you've lifted your foot and you go to set your foot down, and you take the step and you put your foot down, it's right here, right? This is where your foot would land. That's called the run. And on the coordinate plane, which axis goes from right to left or side to side or horizontally? That's the x-axis. So, if you can imagine, we're going to be looking at lines today where we're comparing one point to another point, and how far did we rise to get from our original point to our next point, and how far did we run side to side to get from our original point to our next point. So we're going to be looking at some values that represent the rise. How many units did the point rise? And then how many units did the point run side to side? Okay? And when you get these values, the rise value becomes the top value in your slope, which is a ratio, right? It's going to look like a fraction. And the run value is going to go on the bottom of the ratio, or the bottom of the fraction. So I'll write it again. Slope, which is represented by m, equals rise over run. And that's really the goal today. The goal today is to look at a line, figure out how far the rise is between 2 points. That number goes on top. Figure out how far the run is between those same 2 points. That number goes on bottom. And once you have that written as a fraction or written as a ratio, you have figured out what the slope of the line is. And you'll be able to tell me if it's positive or negative. Okay? Here's what I mean. Describe the slope of the line. So, is it positive or is it negative? And find the slope. Okay, let's start. Let's look at the graph on the left. It's got a nice little line here. I'm gonna highlight this in green so you can kind of tell. This is the line we're working with. Here we go. We got a point here, and we have a point right here. And they give you the coordinates for both points. And I was nice enough to go ahead and put the rise and the run on here for you. I think I highlighted the wrong point. No, I didn't. I highlighted the right one. Okay, sorry about that. First of all, I want to know, is it a positive or a negative sloping line? From left to right, it's going in the upward direction, so it's definitely a positive slope. Okay, now let's calculate the fraction or the ratio that represents the slope. The rise, remember rise is the one that goes up and down. So the rise is 5. The run is the one that goes side to side. So the run is 6. This is the run. This is the rise. What it means is from my original point down here up to my new point up here, I had to go up 5 units to get there. That's the rise, up 5. Go back from my original point to my new point. How far did I go side to side to get from my original point to my new point? I had to go over 6, so the run is 6. So the slope, otherwise known as M, rise over run, up 5 over 6. And since both numbers are positive, I do in fact have a positive slope. Look at the next one. Over here on the right. How would you describe the line starting from the left moving towards the right? Isn't it going in the down direction? So I would say that this is a negative sloping line. It's going down. If you were on your roller skates or on your bicycle, you'd be zipping down that hill pretty quick. Now, let's write the ratio for slope. Rise over run. Comparing this point down to this point. Starting high, going down to this point. The rise was actually a fall, wasn't it? We actually had to go down 3 units, -3 to get there, so that's your rise, is actually a negative number, and that's okay. Go back to your points. Starting here, going here, from left to right, our run was 2, positive 2. So the slope of this line is -3 over 2, and you leave it like that. You don't divide it. You don't turn it into an improper fraction. You don't turn it into a mixed number. You don't turn it into a decimal. Leave it -3 over 2. And it's interesting to notate that because one of these numbers is negative, that top number ended up being negative, the whole fraction is negative, the whole ratio is negative, which also is why we say it has negative slope. So if both of your rise and run are positive, you have a positive slope. If one of them ends up being negative and the other one is positive, then the whole thing is negative, and that's a negative sloping line. So when you come back to class, what we're going to do is we're going to be looking at graphs of lines. We're going to be finding the rise and the run. How far did the point move up and down? How far did the point move right or left? And we're going to be setting up these ratios to represent the slope of a line. There's a couple special cases we need to talk about before I end this video. Horizontal lines and vertical lines. Well, these are special little guys. Okay, let's look at the one that says horizontal line. This is your horizontal line, right? Side to side like the horizon. There you are, you're standing on that nice flat line. You've got your roller skates on. Perfectly flat. You're not moving and nobody's pushing you. Would you roll anywhere if you were sitting on a perfectly flat surface, not moving? You would not roll anywhere. We say that horizontal lines have no slope, or you could actually call it a slope of 0. Because is there a rise? If we start here and go here, did we go up or down at all? No. The rise is 0. The run, going from the left point to the right point, was 7 units. And 0 divided by 7 is 0. That has no slope. There's no steepness to that line at all. And you don't have to say positive or negative because it isn't either, positive or negative. However, on the other hand, you've got a vertical line. Oh boy, this thing's like a cliff. Really, 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 really steep. So if you're on your roller skates and you're standing up here and you got your helmet on, you're feeling brave, and you're going to try to roller skate down that hill, are you going to have any luck there? No, you're not, because that's a straight up and down cliff. Vertical lines, which that red line is, it has so much slope. It's so steep that we say the slope is undefined. It's so steep we can't even measure it. And if I were to do the math on this, the rise on this one from a 2 to a 6 is up 4. And the run from a 4 to a 4, it didn't move right or left, is a 0. And you cannot divide anything by 0. No answer. Undefined. Can't happen. So, vertical lines are so steep that it has an undefined amount of slope. And horizontal lines are so flat that it has absolutely no slope, a slope of 0. Now, this is just day 1 of working with slope. So over the next few days, we're going to be working on worksheets where we're calculating slope based on rise and run, based on 2 points, and based on a table of values. So baby steps through this. Nice little baby steps. All right, I'll see you in class.